So before I give you some practice, let me just give you a quick example. So here, find the limit of sine 3x over x. Okay, so when you look at the graph, it looks like this. But when given this problem, you're not going to be given the graph. So this here, try to use this. You see, if you can get this bubble to be the same as this bubble here, then you know that the limit of this equals 0. If you get these two bubbles to be the same, then you can say the whole limit equals 0. Well, anyway, to do this here, start out by, well, we are here at the moment. What you do is you times top and bottom here by 3. So just so that you can get these two bubbles to be the same. So timesing top and bottom by 3 will take you to here. So we started out as this. So our aim to get these two bubbles to be the same. So times top and bottom by 3. So at the moment you've got this block, and when you times 3, the 3 gets multiplied to the top. So it will look like this. So at the moment you've got this block multiplying with this block, and then at the bottom x times 3 will give you 3x here. So this so the good thing is that this is exactly the same as this. But let's visualize this thing here as a 3 multiplying this fraction here. Okay, because when you multiply a fraction, it gets multiplied to the top. So this thing here is exactly the same as this. But visualize it like this. Now you can jump into here and into here. So take the limit of both. So at the moment you've got the limit of this thing here, but then that equals the limit of this times the limit of this. Okay, and then the limit of 3 as x approaches 0 will always be 3, and then this we will sort out later. So when next time when we're here, we're just going to take the 3 out rather than visualizing as a limit of 3 and then the limit of this here. Because this is a constant, so you can just take it out here. And then just concentrate on this thing here. Well, anyway, this thing here equals this thing here. Okay, and now remember this. Remember that whenever you have sine of x over x, when these two are the same, the limit as x approaches 0 equals 1. So here you can see that these two are the same. These two bubbles are the same. So hang on. So yeah. So visualize it as this. So at the moment we are here. So but note that this bubble is exactly the same as this bubble here. So you can visualize this whole thing here as this. So you've got sine bubble over bubble as the bubble approaches 0. So you see this whole thing here actually equals it's similar to this here. The limit as x approaches 0 will be 1. So the limit of this whole thing here will be 1, because, well, if you think about it, as about if you look at this here, as x approaches 0, that's the same. When you're saying x approaches 0, it's the same as the bubble approaching 0, because by you getting x to approach 0 each time, the bubble itself will automatically approach 0 as well. So for example, let's look at this here, x here, and let's look at the bubble here. So this is our bubble here. This is our bubble here. So look at this. Let's say your starting point is 8. So the bubble, what's inside the bubble will be 3 times 8, which is 24. And then let's say x is 5. Then the bubble is 15. Let's say, can you see x is approaching 0 here? When x is 2, then the bubble will be 6. When x is 1, the bubble is 3. My point is that when you make x approach 0 here, the bubble itself will automatically approach 0 as well. So when you're here, as x approaches 0, well, when the bubble approaches 0, x will approach 0 as well. So when x approaches 0, then the bubble itself approaches 0. So when you are here, you can actually visualize it like this, and then as x approaches 0, then you can actually use this here. You can actually use this. It's the same as sin x or sin x over x. So this whole thing here, is actually 1. The overall thing here would be 1. So your overall answer is 3 times 1. So the limit of the whole thing equals 3. So going back to our original graph, the limit is 3. So when you're given a problem like this, try to get these two to be the same, and then you can use this to make the whole limit equals 1. Well, anyway, I will give you some practice in the next video.